Good evening, everyone. It is with great pleasure that I'm able to welcome Philip Yuan, who is our Thomas Jefferson visiting professor this semester, and introduce him as our lecturer this evening. A highly talented designer and educator, Philip is the founder and principal of the architectural practice Archi-Union Architects based in Shanghai, and he's also a professor of architecture at Tongji University. Philip, I would say, is rare in his ability to, on the one hand, combine advanced technological research with a very active design practice focused on the making of buildings. Few, I would say, traverse this territory between research and practice in this way and at this scale. And on the other hand, I would say he is also rare in the sense of being sensitive to deep traditional cultural building practices, materials, methods, and environments in China, while simultaneously introducing and integrating them with new parametric and robotic practices. The firm's work, which includes a number of projects in rural areas, such as the multifunctional Bamboo Cultural Exchange Center in Sichuan, which I'm sure he'll show you today, Sichuan province, or the recycled brick surfaces of the Pond Society exhibition space, attempt to integrate advanced construction methods and local building crafts and materials. And he uses the term digital tectonics to describe a process that in some way merges traditional craft, its details and methods, with advanced parametric and robotic processes. He sees new technologies as a way to bring back a relationship to the artisanal that we could say has been in some ways lost through industrialization processes, while promoting a very sophisticated culture of making that finds a more subtle relationship between the human and the machinic and the local and global, whereby architects also take back ownership of some of the processes of building and fabrication, something that is certainly highly evident in his own studio and research fabrication laboratory that he also uses as a site of experimentation. Archi-Union Architects were invited to represent China in the 2018 Venice Architectural Biennale. It was an amazing exhibition. I'm happy to say I had the opportunity to visit it, as well as the Chicago Architectural Biennale, Hong Kong, and Shenzhen Biennales, and many more international exhibitions in recent years. They're also the recipients of numerous awards, including the International Architecture Award of the Chicago Athenaeum and a Gold Award from the Architectural Society of China's Architecture Creation Awards. Philip, of course, is also an educator, a teacher. He's currently co-teaching a advanced research studio with Lucia Finney. And he is a scholar and the author, editor, or translator of more than 20 books, including Computational Design and Digital Fabrication, both with Neil Leach, and Collaborative Laboratory, Works of Archi-Union and Fab-Union. I'm very excited to have Philip with us this semester, and we're excited to have him here giving a lecture today. So please join me in welcoming Philip Yuan.
Thank you so much for the generous introduction from Dean Ella. Good evening, everyone. It's a great honor for me to come in here to be appointed as Thomas Jefferson visiting professor at UVA. And thanks to Dean Ella for your kind invitation. I really appreciate your vision, leadership, and your support, not only on the new development of digital technology, but also the important cultural communication in architecture as well. I would also like to thank Professor Li Shiqiao and Esther Lawrence for their special host. Shiqiao is admired as the first and the best Chinese scholar who graduated from AA in the 1980s, which is a glorious time over there. And he has a profound influence in the mainland China right now, especially on the Asian architecture and the urban theory. And also I have thanks to Philippe and to organize the studio and invite me teaching here this semester. So it's a great opportunity and great honor for me to teaching with Lucia. I think we have a fantastic studio and we just finished review. And the students working so hard. I'm so proud of all of your work. So 10 years ago, I worked as a business scholar in MIT with Stanford Anderson, and we drove all the way to UVA. That's the first time for me to visit the great campus, and which witnessed Thomas Jefferson's understanding on the pedagogical campus space and also relationship between the human and natural. A very, very special prototype globally. And nevertheless, this morning, I especially visit the great Monticello, and hopefully, which will address me better to this lecture. So 15 years ago, I founded Archi-Union Architects in Shanghai. The environmental office is a kind of a representation of our understanding about how we would like to set up the relationship between us and the Shanghai urban culture. As the ivy growing in the outer courtyard of the office, we progressively making our dream through the expansion of this physical space. So the garden actually embracing the office, and the office also embracing the courtyard greeneries. In ancient China, garden is not only a physical space for leisure behaviors, but also a dream space reflecting a holistic view towards the harmony of body and nature. Ji Cheng, a gardener of Ming Dynasty, in his book Yuan proposed concepts such as borrowing the screens and being adapted to the local artificial conditions, which are actually representation of holistic view on human and nature. Moreover, to be specific, garden is not isolated from the outside world. Rather, it is regarded as an extension of the limited human space, forming a continued artificial connections between the human body and the surrounding world. Dian Chunyi is a garden inside the master of a nest garden, which is although not the largest, but one of the most representative in Suzhou Garden. Metropolitan Museum also collect this garden, named as Mingxuan, and which is on the second floor of the Metropolitan, reproduce it in the New York City. And recently, Luca Molitani, who is the former curator of Milano Triennale, curated a special contemporary exhibition in this garden, which I was also involved in. So through the robotic plastic printing technology, we create an artificial stone and embed it into the context of Dian Chunyi. Then in this view, we can see 3 different rockeries from the 3 different time periods. The middle one is real one, actually, which is a natural formatted Taihu rockery from the Ming Dynasty. And the upper one is artificial craft stone made in the period of Republic of China. And the lower one is in our exhibition. So which was used recycled plastic. We're thinking about this kind of post-humanism, what we can produce right now as part of the traditional Chinese garden. We implement robotics and to print them in like 2 days for this big rockery. By involving into the continuous making progress of the garden, we would like to propose a contemporary view on the relationship between the artificial and natural. In the original context of Dian Chunyi, 2 Taihu rockery were set up through a projective alignment. Actually, you can see the 2 rockery, and this one and that one is this rockery projected to that one. So that's the original story, and which is very famous in Chinese garden history. And the way of our project is to intervene the binary relationship formed by the 2 existing stones by placing another mirrored stone on the ground to reconstruct a ternary relationship between the 3. So that is a new production process to engage into a very traditional Chinese garden. So in ancient time, every garden just like a family, like 20 to 30 people live in it. So people will have different kind of behavior, sitting on it, lying in different stone. But right now it's a contemporary behavior for one of the visitors just lying on the stone. I think it's kind of a new, interesting event space for the traditional Chinese garden. So here is another story about the tea house, which located in the backyard of Archi-Union office, and which is constructed in 2009. It's almost like 10 years ago, and construct from the salvage parts of the original warehouse collapsed roof. The site was extremely restricted, with a wall on 3 sides, and with only one side facing towards the special pond. And there is one tree there. We do not cut down the tree. We try to design certain kind of relationship to engage of new building with this tree, the original tree. So the ground floor, you can see the space just facing the trunk of this big tree. You can see a very big trunk from the ground floor in the tea house. And second floor, you can experience the shadow of the leaves, the sunlight from the outside. You can certain kind of experience of this sunlight. You just kind of touching this kind of leaves from the second floor. And we have another back space. You can see the leaves falling down to the balcony on the second floor. So it's a super small space. It's just like 120 square meters building, 2 stories. But we have 3 ways to have a special set of special relationship to just one big tree. So the interior space actually is interesting. We try to embody the harmony by integrating the exposure and openness, the delightful space and logical construction and other complicated relationships. The building reacts to the site's environment. The main object in the tea house is a stair. So it's the integration of the circulation and the background, which is a wall and which is also a stair. And then maximizing the amount of space and letting you take a different experience on the tree. So this is one big object, although it's a super small space, but it's just one big object which dominates the space and give the new spirit, new identity of this small space. This is our neighbor, also beside us, a ceramic house for an artist. The 2 stories building slightly attached on the 1 floor old facade. We did not tear down the facade. We just construct the building inside the old building, 2 floors inside the 1 floor's building. And simple plain materials such as brick, wood, that naturally coexist and integrate with each other ideally. The old wall represents a sign of timing, which becomes the unduplicated characteristic feature of the site. So the traces on the facade, you can see the history, which is like the different time. We have different kind of trees on the traces on the wall, and being kept as a responsive tectonics, rebuild identity of the context. Also, we keep one of the tree in front of the second floor, in front of the house. The big tree becomes the shading for the south balcony, which prevent directly the side exposure from the road and provide a diversity light and shadow on the facade in different seasons. The old building is one big tree, which is a feature in the existing site, rather than remove or replace them with a brand new object. We build like the reality nostalgic context and take the old as part of the new. So it's like the object is integration from not only the interior of the space but the exterior, even though it's a tree or the existing warehouse is part of the new environment. So we want to re-emerging the site memory through the new construction process. So the right side, the axometrical drawings is a whole office with our neighbor. Actually, the office we name it a HYPEROBJECT, which is like a contemporary Chinese garden. Integration of inside and outside includes tradition courtyard, exhibition space, design studio space, tea house, robotic yard, and so on. We became confident to see the world through this very special as a platform to us. It is supposed to be just not just an artificial office, but a research laboratory as well. I'm trying to propose this an alternative vision on architecture authorship, which could be established not just through the design projects for the office, but more through a model of research production. In this sense, the traditional definition of the architecture practice would be transferred to the praxis, a design application of knowledges. In the past 9 years, I have been setting up working together with Neil Leach, we're setting up a particular research platform named Digital Future Shanghai, which is a PhD program, workshops, conference, and exhibition-based event. Every year, we invited 6 to 12 teams tutored by experts from all over the world, including like Philip Beasley, Tom Mann, Philip Brock, Archimangus, who have been intensely packing everything, teaching together in 2 to 3 weeks, and focusing on a certain research topic on computational design and robotic fabrication. I think it's kind of a learning progress. Archim's team coming 5 years, and Philip Brock coming 3 years. I think it's like a very interesting event. Everyone teaching each other, learning from each other. We're sharing the knowledge with each other. It's totally open platform to all the community, the society. So you can see the parameter for the participants is increasing. The first year we have only 30 students participate to these events, but year by year, the big number. This summer, 4 months ago, we have 220 students from 126 universities from all over the world participate to this special event. And our global partner who teach here more than 40 teams, including North America, including South America, and also Europe, Australia. So we're sharing this kind of open culture with each other. So it's a great honor for us to have this special event. And we invited several important contemporary philosophers, theorists, and practitioners to Shanghai. And the intention is to form various discussions and dialogues with Western and Eastern culture and to reconstruct the new context for exploring the future of architecture. Although from different perspectives, these philosophers have a similar tendency in their thinking, reframing a post-human view in the age of Anthropocene. According to the philosopher Andy Clark, as human beings, we are natural-born cybers. It is perhaps our human nature to adapt to the new tools so that they become our prosthesis. Due to the plasticity of human brain, new technologies could be constantly absorbed within our body screens and become extensions of our body. Merleau-Ponty describes the two become incorporated into the extreme body schema as a kind of a prosthetic bodily extent that allowed us to experience the world through it. What's the difference between the prosthetic hand and the human hand? Could data flow be able to deliver human emotions and perceptivity? So as a corresponding to Andy Clark, what we're doing in the last few years, here is an in-house robotic yard. The Gantry Robotic Factory was set up in 2015, which spent us like 3 years to settle down everything and follow the dream of fabricating the future. We developed actually the heart of the future robotic factory inside our design studio. The range of this work is like 10 meters to 14 meters, and the height of it's 8 meters. So on this platform, we developed 12 different kind of crafts, including robotic timber structures, 3D printing, etc. I think the essential part for this special configuration, from configuration to the robotic platform, and also we put more than 10 different kind of sensors into this platform. It's like the robotics, like the extension of the human hand. You have 2 hands. One hand can carry 125 kilos, and the range of it's like 10 meters to 12 meters. So it's expanding the scale of the human body, actually. And we put the sensors in it. It's like you have eyes, you have skin, you can touching, you can have the real-time feedback. And this is extremely important. It's like this platform is expanding of the human body in the construction, the experimental construction process. So, and also some other theorists, philosophers coming, and based on the theory of artificiality, astronomy, and automation, Benjamin Bratton's terraforming envisage a total transformation of the Earth's cities, technologies, and ecosystems. The project takes a position of blur the boundary between the artificial and the natural. It treats urban scale automation is seen as part of the living ecology, and considered the city as a planetary network by which humans occupy the Earth as a surface. In a way, we try to outline a planetary design initiative for the next century. Stiegler, I invited him to come to Tongji 3 times and teaching in our PhD program. And he's sharing a similar holistic view. Stiegler addressed the globalization of exchange due to the global communication networks, the worldwide internet and the GPS system and the cloud, etc. He sees the network as a planetary infrastructure allowing the permanent interconnection of 2.5 million individuals, which activities are systematic traces and treated by the intensive computing. So he is pointing out our new mission is to rethinking on the smart city, which may only follow by the rules of computation that would be a threat connecting between the human being and the cybernetics. On the opposite way, he pointed out we should think about if we could establish the new urban genesis, which embracing human internal vitality and increase the matter efficiency to reverse the entropy of the cyber world. So I think Stiegler gave us a lot of influence to the attitude of not only the architecture design, but also the urban vision. So when applying the philosophy into architecture, then we could simply raise a more specific post-humanism question. Is architecture necessarily designed for the human or by human? In the context of hybrid objects, the answer is obviously no. As Peter Schumer, we invited him coming 2 years ago, the architecture in the age of hybrid objects could be designed for something bigger than human itself. So today I would like to analyze 3 main topics to interpret architecture as a hybrid object. I think it's through the motivation and the paradigm, formal paradigm, and also the methodology from 3 perspectives. The first, the non-local then lies in the emphasis on the form making over form making, form finding over form making, on bottom over top down process, and on formation rather than form. Indeed, the term form itself should be relegated to the subposition of the term formation. Meanwhile, formation must be recognized as being linked to the terms information and performance. When architecture is informed by the performative considerations, it becomes less consideration for form in and of itself, and more a discourse of material formations. So this is 3 bridges, actually, we designed in the last 3 years as a brand new design process, re-understanding the materiality and design process from the perspective of performative fabrication. So the first one is a plastic one. Here's a flat bridge, and also we have an arch bridge, which is located in our college. So the flat bridge crosses the small pond, but the arch bridge actually crossing from the ground floor to the basement. So the very first thing to design this bridge is finding forms. So in this stage, the progress can be divided into 3 parts. The first, we implement the category as a formation to find the upper boundary and the lower boundary. So I think that's extremely important methodology. Like category is developed by the structural engineer, but actually the architects right now can implement them in the design process. And then we use MIDI-PADI, which is a structure optimization software, and to based on the topological optimization methodology, and remove the unuseful material in the construction. To do that, we also need to set up boundary condition and remove the unuseful material, and finally we find the useful material. The most important, we implement the robotics, the 3D printing, the forces followed by the density of the material, and the print material is the structural material. So, which is totally based on the parallel fabrication on the platform, university platform, and also in the Fab-Union platform. So this is testing Patrick Schumer coming in our workshop. We're working through it. This is the first year standing on it. So maximum, we're standing 5 people on this plastic bridge. So it is a pedestrian bridge. Totally done everything by my student. But because of the hot weather, unfortunately, after 45 days, that year, 2017, extremely hot in summer, 42 degrees. So we're testing it, detected every day. So the top of it like 72 degrees, and the bottom of it like 39 degrees. So the temperature difference make a huge transformation for the geometry system, geometry of the bridge. So it's broken down because we're learning a lot through this failure, the first year. And this is the second year. We 2018, actually, we invited Wang Shu, who is a prize winner on the right, and Mijin Yun and Nader Tarani coming to make keynote speech in Digital Future event. So how many? 7 people standing on it. So this is totally updated version for the efficiency of the bridge. So technology we implement this time is 3D welding by the robotics. It's like point-by-point welding. The structure optimization system, which is optimized by different softwares. And it's interesting, everything finished in two weeks and a half. So this workshop for making this special bridge. And Wang Shu told me he is very interesting, maybe not the progress how to make it, but he is interested in this kind of details, which have a certain kind of quality of the craftsmanship, which is totally by robotics. It looks not accurate precisely, but have this kind of very interesting details. But it's made not by human being, it's by machine. So it's by the collaboration between robotics and the human being. That is what name it's cyber. It's a cyber future. This is this year. So you can count it, how many people standing on it. So it's a learning curve, right? 3 years. From 5 people to like 20 can standing on it. So we spent like 20 days designing and fabricating this bridge. The structure spans 11.4 meters and the rise is 3.9 meters, connecting the ground floor to the basement. With millimeter construction precision, the main structure thickness tapers from only 20 centimeters. With help from Maxia technology, we use Amoeba, which is special software to optimize and use BSO to generate the form to support the whole system. So it is not one material. We use 3 kinds of material, including the steel metal welding and carbon fiber and glass fiber, 3 kinds of material. So it's integrated material. The robotic 3D metal printing offers more freedom back to the designers with excellent strength to weight ratios on it. And this is a weaving for each local steps. So it's 3D welding and robotic weaving on it. So with excellent strength to the weight ratio and the scale limitation determined by the robotic reachability as an excellent production method, robotics filament weaving technology becomes a great method from the geometry as a local structure like the steers and the handrails. Through the composite structure, the joints research aims to maximize the structure performance and minimize the material usage. So the weight of the bridge is only 450 kilos, but 20 people can stand on it. So it's extremely high performance bridge. You can see we invent all these tools, and all the process is simulated and fabricated by the robotics platform. So it's a carbon fiber and for the compression and the glass fiber for tension. Yeah. This is a gantry robotic system. We record the whole process and all done by the students, graduate students. So all the segments are pre-assembled into 3 parts. Steers, actually we have 18 steers. And then we put them together before the final day. So you can see the details. And also you can see this kind of welding details by the robotics making. So it's 3 layers. We have a support system, which is 3D welding. And now we have the handrails and the steers, right? So it's a skeleton and with different kind of muscles on it. It's like the 3 layers of system. So everything very intensely in 2 weeks. We fabricate them in our school. So it's like an event, special event every year to present what we're doing, our research and our special test through the same topic of the research. So this is we name is like one object. So you can see the material and the details is totally recreated and fabricated by the material performance, right? So the bridge created by different material is actually, which is a totally experimental research process. So the ultimate objective of research is to experiments. And through the experimentation, to establish a kind of credibility so as to analog the scientific laboratory, the design laboratory would leading a rethinking on the tradition authority of the architecture design. So I want to talk about the hyper-object paradigm, the second topic. Then the progress of the performance-based design is framed in the vicious environment in which every hyper-object is dynamically connecting to the others. And each architecture hyper-object have an instinct system. Their vicious relationship would cause the continuous transition between each system, so forming a different kind of dynamic and uncertainty through the architecture space. So we want to put forward some examples. The robotic developed by different kind of material, the brick mansion. So this is an exhibition we participated in Chicago 2 years ago, and the right to one were collected by New York MoMA. We present the object there. It's quite a nostalgic object there, but actually it's totally fabricated by the robotics, the 3 projects. So Chishe, which is known as a pond society in some media platform, and the story of the harmonious combination advanced robotic brick-mansion and historical traces. In this project, form is not just looking, but we want to implement the different kind of new technology to just fabricate the tradition and the recycle use bricks. And Professor Philip Rusman, who is the dean of ETH, recognized this project as a piece of the matter and the mind, he mentioned, because he can read not only the technology, but also the culture, some cultural aspects. So the most important, we put the sensors on the robotics, which is to scan and recognize and provide the real-time feedback of the unique characteristic of each non-standard recycled brick, which help us to precisely place each brick to achieve the global geometry form, piece by one by one. Yeah, the coexistence of roughness and accuracy is what we would like to express during the collaboration between the human emotions and the machinic intelligence. So the most important, we program everything, every pieces of the stone, and actually which is totally based on the simulation tools. You can see the deformation the stretch, and then also the wind load, which all the parameters was translated to the density of the material, and we just translate the kind of density to position them in different place by the robotics. So interior space with light and with very small space, but we find special quality based on this connection to the context. Another project have this kind of continuous and have this kind of gradient changes is the Fab-Union space. The Shanghai government developed the West Bund, which is a very popular space right now in Shanghai, and gave 5 architects and 5 artists special space, and we organize different events there. We can use the space for 5 years, so it's interesting special event in Shanghai. So Fab-Union is belong to our team, so we actually set up a lot of exhibition on that. So everything was constructed in 4 months, including design. So it's extremely short time. So the space is from the program. Actually, we have 2 higher space, 5-meter space, and 3.3 meter space. And we just gave 3 meters in the middle to set up the circulation and the very special space in the middle to design everything. So this is the circulation. We integrate all the different kind of platforms. The most important right now, teaching my student in the studio is use the same methodology. We use Amoeba to optimize the structure, delete unuseful concrete, generation by generation. So the iteration have 84 or 82 generation. And afterwards, we just translate this kind of geometry and just polish them to some support system. And the right bottom is the tradition structure software to prove what we're doing is right. So it's by Amoeba, it's totally new software, but we optimize and delete unuseful material and try to create a new kind of experience space inside. So the construction process is really complicated in very short time, but we join, make a lot of sections, but the workers cannot read these kind of sections. The only way to teach them how to construct it by models, actually. So the plans, it's difficult to position them, but spatially, just by models and teach them on the site. So after the construction, you find the space quality is totally different. The wall is maybe not just a straight wall. The wall could be like a folding curvature wall because the forces are flowing. The support point is here. It's like all a big diagonal linear space which support the second floor. And the second floor is something like this. We have outer space and we have some stairs inside the big volume. So it's like a transform from one point to the other. It's totally redefined the space by the structural performance. I like this image a lot because we have the light washing the concrete from the right hand. And on the left hand, we have like a parallel light which also washing the concrete. Although the space is extremely small, like just 14 meters, but we have 2 kinds of light. We have very special structure system, which give us a totally different experience. So we organize different kind of event there, including different artists. And right now it's like a structure, a furniture designers make a special exhibition which opened 2 days ago in this space. I think it becomes open platform, not just because of design, but it's kind of a communication and dialogue and the collaboration with different designers and the new generation. So we try to promote this kind of a new technology. We have a profound influence in the big society. And another topic is cyborg crafting. I think furthermore, the interobjectivity of the hybrid objects could form a view of the architecture production based on the automation and machine intelligence. The architecture hybrid project is not only conceived, integrated, and fabricated by human beings, but would also be other hybrid objects. The computer and the robotics could be part of the, which is collaborating with human being. It's part of the hybrid object. So that is an interesting topic. We set up the prefabrication platform, and also generation by generation, we have some in situ robotic platform. This is 3 generations. Actually, right now we have the 5th one, which can climb in the scaffolding, and it's like generation by generation iteration of this kind of different platform, and which is extremely important to the authorship because we're not just design project. We help the the fabricator, the contractor, to think about how to construct all the buildings by different methodologies. And also in the last 10 years, we developed a FU robot. And this time we open this platform to my students here, to the studio. I think it's based on long-term work by my PhD student. More than 5 students working on that, around 6-7 years. We started 10 years ago, but starting working it's like 6-7 years. We program all these kind of tools, craftsmanship, the extruders on this platform. And anyone would like to use it, we can just open everything to them. It's like a totally shortcut to use this kind of new technology. So the FU robot is a visual simulation and a control operation platform, and which is seamlessly involved the architectural geometry Rhino and into the fabrication process. And the plugin of Grasshopper of this one is we have some real-time feedback, and which is extremely helpful to the whole design process. And most importantly, it's a learning, sharing, and collaborating platform, because other people you can put your extruder, for example, on this platform, and others can also learn it from you. So it's become open source platform to everyone. So most importantly, we bridge not only KUKA, but also ABB and HR, which is different brand, which is totally different kind of scripting, but we develop certain tools to bridge this different brand of robotics. So that is fundamentally a very important platform, which is like the interface like this, and category by different kind of craftsmanship, different kind of platform. And this time we just, the students right now, they use this kind of platform plugin with kind of bandsaw, flat saw, or just milling machine, and also everything is already programmed. So right now what we're doing is collaborating with different kind of fabricator, and they can very fast learning this kind of new technology. For example, the most important collaborator with us in Suzhou, to the end of this year, they will have 80 robotics in their timber structure factory, but they totally use this FU robot platform. So that is, I'm talking about the authorship. I'm not just talking about design. This is based on the PhD program, and which is research, and the Fab-Union every year support back to the PhD program. So it's like a very interesting ecosystem from research to the practice. So in this situation, we would create a mutual cultivating relationship between the design research and the building practice. And what is Latour's notion on the scientific result would only have meaning through his position in a network. Then the meaning of design research would only be reviewed through the relation to the practice network. Otherwise, it's just on the paper. It's paper architecture, right? But this is like we bridging the research to the design quality. So this is 2 different things we want to talk about. And this is I already mentioned Venice Biennale. We competed for this project last year. You know, in China, we have an extremely big architect society. So we compete this project because we have the unique tools to make different kind of design totally to the other designers. So the location of this pavilion is sitting at the end of the Virgin Garden of Asena, and our neighbor Italian, the local Italian pavilion. So which is a very peaceful and calm platform, and people should work in like 1 hour to the dead end of this pavilion. So I'm trying to design a space for people, they can take a rest and sitting down, which have the canopy shadow. So it's a resting space. So it's not just a technology space. I think it's very important we try to make design for people, design for the behavior of the people. So this is a building. And then I just very quickly jump to the process, how we make this cloud village. We name this as a cloud village, a special object. So the village contains 4 enclose the cube objects, which are organized together by a shared linear roof. To enhance the overall structure performance, a series of topological optimization algorithm was applied to optimize the form of the pavilion. The flat roof was turning into the wave geometry based on the density of forces, the stiffness of the forces. So the structure was divided into 50 pieces, actually, and we printed them pieces by pieces. And the material we use is recycled material, which is a friendly, environment-friendly material, because the plastic is a real critical problem right now to all of us. And the technology we use, we name it as digital twin. We have the simulation tools, we have the fabrication tools, right? And we printed them by 50 pieces and assemble them on site. So this is a 50 pieces, which optimize and in the design process. So the fabrication process in our lab. So the materials, we make some research on the materials and testing different kind of plastic. And finally, we find a very good performance material. And this is like the printing process. So it's autonomously printing like spatially, point by point, and simulation fabrication with a digital twin in the whole process. So this is one of the largest pieces. We record the process, how to print them. It's like 2 to 3 days to print the whole piece in the robotic lab. And then we're packing them into the container and transport to Venice. So the most difficulty in Venice, we only have this kind of gondola, right? We should just moving them through big ships to via small ships. So one of my PhD students with 6 graduate students working together for this pavilion. It's like 7-8 days to finish fabricate everything. So this is a process for this research project. Because Venice is not allowed to dig in any foundation, so we need to put like a sand as a foundation, which is hidden in the bench to balance the whole load, keep the safety of the pavilion. So the trees on the side was which we previously scanned by the drones, and which becomes the boundary and the pavilion. Actually, the curvature for the pavilion, which fit very good to the drones scanning. Actually, it's kind of a design process, find the relation from the object to the environment. And also can this kind of framing the China pavilion, interior pavilion and outside, which have a strong dialogue, this kind of semi-transparency to the brick mansion structure. So it's kind of dialogue from the future to the past. And another we want to special craftings we want to introduce is like robotic carpentry. The details I already introduced to the studios here, which is very interesting in China and Japanese history. We make a huge research on this kind of structure system. So this is one of the Digital Future event, and the whole tower was divided by 12 layers, and more than 840 pieces. But everything, all these kind of things was fabricated in 2 weeks and a half. So this is the optimization process, right? So we implement the bigger robotics. You can like faster fabricate this kind of components. So this is based on the computational design and the robotic fabrication technology. The traditional crafts could be embedded into the new interface between the human and the computer collaboration. So the students, they have no experience in carpenter, right? They are not carpenter, but everything is, they can control everything precisely. So this is a process for the like all the technology right now. We working together with the students here. I think in our studio is we try to fabricate this kind of components and by this kind of the same technology. And this is a project we implement through the research to the real project. This is a special village located in Sichuan province, which is like 1.5 hours away from Chengdu. So also this project was invited to present in Venice Biennale last year. So we designed actually only 6 buildings, and which totally changed the identity and the lifestyle in this small village, including a community center and also industry presenting center and some different kind of B&B and different kind of programs like camping place there. So the first time I was invited to the village, I was deeply moved by its historical environment and the natural beauty. So what we design on the site is actually all the materials very familiar to the local people: tiles, timbers, and also the bamboo weaving on the facade. But the structure system I think it's totally different. We prefabricate everything nearby Shanghai, Suzhou, and by 6 big trucks transport all these components to the site. So it's a prefabrication, and on-site work only 52 days to construct this building, 1,800 square meters. So this is I think the meaningful for this is not just the form, but I think the working flow and how we give a different kind of identity and quality to the rural area of China. And this are some B&B, and these are some different buildings. So this community center we name is In Bamboo project, which located in the rural area of China. And we present the roof as a special big object, the HYPEROBJECT, which is one system, like homogeneous system. But the geometry is totally new. It's kind of double curvature, twisting, two round shape twisting together. And this geometry, maybe roof, not a roof become the wall, and this is one system. It's totally a new object, and set them by layers of the material, the traditional tiles on top, and the speciality for the construction, all the pitch and degree are different, so all the joints are different. If by human being, it would be extremely like the carpenter will spend a long time to fabricate everything. But we counted the column and beams, which is total like 324 pieces, and fabricating in Suzhou, like only 2 months, very precisely, fabricate all the joints, because the school need to passing through 2 times the timber, 1 times the steel panel. So it's kind of very strong position for the whole object. And also we have some curvature beams, which is fabricated by our special bandsaw we invent, and teach the fabricator how to implement these files. So the detailed drawings are not sections, plans. The detailed drawings are these files, you see? It's all the data, right? We send from Shanghai to Suzhou, they can fabricate everything. Every piece is like 6-7 hours. Yeah, so that's the future we're talking about. So in bamboo, which is hidden and visible, hidden in the bamboo forest, and the background is still the natural, right? And you can see the traditional material, everything is familiar, but everything is totally different. So we can see the quality of the fabrication give us a strong opportunity. So everything is the same, because including this kind of farming land, allotments is still there, and people just farming surrounding this building. And also we did the design 1, 2, 3, 4, 6, 8 B&B, small building, which has a very small courtyard in the middle. So we implement this kind of tiles on the top of it. And also each courtyard have trees or have a lotus in the middle. So the local people told me it's super familiar to them, but super different, because all these kind of curvature roofs are prefabricated in the factory. So a lot of event which gave special activities happen in this village. People gathering and invite people, make performance here, and some young children visit the community and organize different kind of events there. So it's like a building change what's happening there. So this is like an entrance pavilion. So I making this model one night, and the local master there, he fabricate this, weaving by his hand for this special entrance pavilion. And I find before the opening, 2 days, some workers working on the site for the greeneries. So this is a picture I took one of my visit before the opening. And the most important, I asked them, where are the mills? And I talk about my husband working in the big city, my sons after graduating from the school, the college, they want to find a job in the big cities. So that's the phenomenon, what's happening right now in China. It's totally different than the States. I think it's kind of unbalanced from the rural area and the big city. So what I'm doing right now is try to teach our platform, like Webview Robot. And the local people just set a very small, like timber structure factories, so they can fabricate their own like house and like public buildings. I think that's totally new to them, which is just attract the people coming back, the young generation. After they learning some computer, they like playing iPad, right? They can just control the robotics right now very easily. But I think it's a kind of new job opportunity which can help them to set up their own business. I think the technology is not just about in the laboratory, right? Which is about how to collaborating with the social process and social networks. And then I will switch to another 2 projects, which is what we're teaching together with Philip Block at the beginning of this year, which is ultra thin structures. So this Philip and me, we standing on it to make the point load testing, and we're jumping on it. Right? So the thickness of this structure is only 3 layers of brick. So that's a special, and this is an asymmetrical freeform arch generated by Renovolt. Renovolt is developed by Philip Block, and our team's contribution is to 3D printing this scaffolding in 8 hours, which is super efficient to support this whole system. So we find the geometry printing in different ways can make different folding to make generate different kind of supporting form, and very strong stiffness. And people, MIT students, with my student, they can sitting on it. It's very strong. So what we're doing is printing them in a very short time and just find the geometry and putting them on the side. And then we put the tiles and the brick on it, layer by layer. It's only 3 layers. You can see the space quality. After take away the scaffolding, you can find this free-form geometry. It's a kind of new technology, totally new technology. But the research is based on the collaboration between ETH, MIT, and Tongji. So it's a research project. And afterwards, after 6 months, still working with Philip Block together. He's a very good, excellent structural engineer background architect. So this time, we're experimentally doing much bigger. So last one is 60 square meters surface. But this time, we're going to another 600 meters. The red pavilion is built like 600 meters of surface. The design for the red pavilion start I think it's April this year, so and finished like two months ago. The special for this pavilion is the people can have a kind of special detours because it's located at another project the project I want to introduce later, which is super big campus. But the special for the experience to visiting here is to find the position for the observation from different height. So this very small pavilion can give you opportunity to working like spirally to find your position to take a look of the environment. That is totally have some connection to the China pavilion. In China pavilion, if you visit Suzhou, a lot of rockeries you can working around. And to find very small rockery have a very big word. They are talking about this kind of metaphor in the Chinese tradition. So this is multi-layers. We have scaffolding. We have some supporting structure. We have insulation. So everything is real. But the most special I want to tell you is we have only 3 layers of brick this time. the span of the structure is 45 meters. I think which is the biggest rhino vault in the world we constructed. This is the facade section for everything, and surround and put them on the water. So this is auditorium for the special event for the international conference there. So reflection of the water to see the space, have a special dialogue to the environment. And the people can walking around in different position to see the whole site, right? So we have a special video for this one. So the red pavilion is a large-scale brick shell, which complicated and generated by the 3D equivalent of compression structure action, and built with a novel 3D print framework system. This is form diagram and force diagram, which generate, and this is a scaffolding system. We have some insulation to support the whole bricks, and people can walk around on top of it. So it's multi-layers of the construction system. So the fabrication process is with 3D printing reciprocal different components, which is a self-support system, and also we spray the insulation on top of it. And afterwards, we assemble them on site. This project will finish when I was invited teaching here, actually, in the last few months, very fast. So it's also, so you can see the brick, everything, layer by layer constructed. And the most important, the regulation is no regulation for this building. So we test the half load and the full load, 50 tons. That means 400 people standing on it. So that is a dead load, extremely dead load for this building, for earthquake, anything. So we test it and prove it and show it to different juries and passing through by the regulation. So the people standing on it have an observation point by the very special structure system. This is newly finished, just 1 month, 2 months ago. The interior is an event space. We organize different kind of exhibition or the lectures in this interior space. So this is 3D printing scaffolding. We did not take away, just put there on the ceiling, right? So this is a process I want to present here. It's from totally research work to the real project, which is happened in 6 months. And that small pavilion goes to the big project, my office design, and in the last 6 months, actually, after Chinese New Year, which is March, they're looking at us to design this super big project. So Wang Shu designed the phase 1, which is something like here. And this is the old town, and this is the boundary of the new town. They want to make a Wuzhen Internet conference space, which is expression of a new surrealism style endowed by the era of the south of the Yangtze River. We name it Jiangnan. So I think the problem for the competition, a lot of teams, including GMP, different teams participate to this competition. So we would like to say the new building space here defined as a stage for the new activities in the post-humanism. So Jiangnan, which is a very important location of China, which have a very strong culture and traditions there as a water town. But right now, some new events put into this area. So they are organizing, they need bigger space. And how to find a special context to engage the new building into the traditional environments. So the complex, including one big exhibition, 30,000 square meters here, and also it have a conference center here. And we designed 4 different pavilions here. And this is by the brick and the 3D printing technology. This is by the brick mansion by robotics. This is robotic timber structure, and this is plastic printing. So 4 pavilion test for different technology. And the big one is also designed by my office So in order to meet the functional requirements of the World Internet Conference and the future different operation requirements, the whole building was divided into 4 exhibition space. So we have different kind of facility space subdivided them. But the most important I want to highlight is the whole space with no column in the middle, because this kind of 100 meters are kind of hanging suspension structure. So it's no column in the middle, it's a continuous space. So in terms of the structural efficiency, suspended roofs with suspension cables or steel strips require lower amount of steel, but the construction control and the detailed design of the flexible system are relatively complicated. So in between the mainstream beams, we created and proposed like a cantilever beam, which made by a different kind of steel structure. And the structure prototype is derived from the suspension structure, different from the conventional suspension structure. Here we're putting tension on the steel and to get the maximum mechanical property. So it saves a lot of time for the form finding process of the cable and replace the steel cable with this kind of I-shaped beam to realize the complexity of form. So more than 230 catenary beams are unified into the circular segments, which have the same readers on the ceiling system, which is an extremely difficult structural system. But everything here was constructed in 6 months. So in order to achieve the rapid construction of the entire pavilion, it should be lightweight, should be easy position, and the dynamic of the modular system and the logic of the full prefabrication applied to this overall scale construction of the entire pavilion project. The prefabricated upper building structure itself and 8 different columns support from the site and to generate the whole form. So it's gradually break the mathematical logic. So the roof, 20,000 square meters. So we have like 300,000 pieces of tiles, which is a traditional material, we put on the roof of it. I think the most important for the geometry is that the boundary are very low and the main beam very high. So although it's a continual building, we have different layers. You can see from the side, it looks like not one big building, it's like the multi-layers of the building. And also we have the aggregation on the facade, which is generated by semi-transparent layers and for the facade system. And we have some deep skiing space, and it's very rainy in the Jiangnan area, so it's like a very long linear space. We can work through the side of it. So this is a construction process. You see, everything is based on the structure and architecture collaboration. So it's one system. So precisely define the system and precisely, accurately make the construction process very reasonable in a very short time. So this is after the fabrication construction. We can see the full pavilion with the whole environment. So the full pavilion located in the future will be a small forest, and the trees will be planting next spring, and 4 pavilions there with very experimental, with different kind of quality, which is like a space there. So at night, it's semi-transparent. So it's a very light, like the roof, like a hyper object hanging on the top, but the building is transparent. So this is like interior space, something like that. It's extremely 100 meters, 250 meters, this whole building, with the main beam on the top and with some catenary linear column on the top of the roof. And also we have 3D printing. This is plastic stubbock, which is on the side of the location. But everything was 3D plastic printing, because plastic is a recycled material, right? We use everything, including the table, including chairs, everything is 3D printed. Okay, so the fabrication, I want to make a conclusion, has been developed to acquire an understanding of the new materiality in architecture. I'd like to extend the subject of matter to include not only the materialization process, but also the vision of design and construction as a foundation of architecture discipline. Fabrication should not only be interpreted in terms of the building technology, but also inherent in cultural and ethical aspects like place identity and post-human identity. In that sense, fabricating an architecture object becomes fabricating a hyperobject, an object according to Timothy Morton that is a massive distribute in time and space relative to humans. Fabrication as well as architecture would become an entity moving beyond the individual physical object, beyond the individual human cognition, eventually to be immersive with our social networks, our cultural context, and our natural environment. So that is today. Thank you. Thanks for your attention. This is by robotics, learning my handwriting, training the robotics. Yeah.
We can open it up for a few questions. I know it's all crystal clear to all of you.
So, in your firm, do you have your structural engineer in your firm, or you collaborate with? Do you have structural engineer in your firm to work on that pavilion, or you hire someone else?
Yes, we are a Class A design company in China, ranking different hierarchy. We are the toppest. So we have in-house structural engineer, but at the same time, we're collaborating with Mike Xie, with Philip Brock, with Bollinger, this kind of worldwide known structural engineer. They give us some conceptual design, which is very important. And also we have the in-house structural engineer working with us. So okay. That's because it's super fast project. We must have someone working very detailedly to everything. So I think the future is kind of integration between architecture design and structural engineering design. It's not two disciplines right now.
Yes, because from what you showed, it seems like it doesn't need to design it a generation from the software, then the structure show up.
Exactly.
Philip, well, first of all, thank you for a phenomenal lecture. It was really extremely powerful. In many ways, you speak about this seamless relationship between sort of in architecture, engineering, and software, right? Mm-hmm. But also in many of your projects, there is a very sort of clear reference to certain architectural sort of predecessors that, of course, either have informed it or have certain formal similarities, right? So if you actually look at Eladio Dieste, for example, in Uruguay, and the sort of curved brick, right, at the wall that starts in a line and then sort of becomes a curvature, or his sort of famous warehouses, which in many ways, the last project that you showed is an incredible sort of take on that in a much more sort of digitally sophisticated manner. So I wonder if you could speak a little bit about sort of, despite the shift in software, where do you think sort of this continuum in terms of sort of architects at the confluence of architecture and engineering, where do you fit within this larger continuum, and who are the figures that you find most inspiring?
Yeah, it's an extremely good question, actually. We make a huge discussion, actually, this question year by year in our different event, because that's a really critical question for the future, because we're talking about this is a cyber future, followed by Andy Clark is like post-humanism is like we're not human-centric. We should working together with the environment, and also we should working with the kind of cybers like machines. Machines becomes intelligence, which can balance, we can extension our human skills. Right now, the intelligence is not a human intelligence. It's like a human-machine collaborating intelligence. But the problem, the critical point I want to put forward is, in the future, if we have machine intelligence, where is the position of human being? I think human being is still should control everything. it's like we are talking about Stiegler. He's really critical to talking about the smart city because everything in China, I don't know here, in China, every square and the big public building have that face recognition system. It's like everything is smart right now. But it's really critical is this kind of smart can give us some opportunity for the future. We will say no. So what is a good part for that is to give us some vitality and give us some like high performance, which is based on the intelligence, which is based on collaboration between human and machine collaboration. I think it's like the negative entropy process for the future. So it's like a school or firm is same. I think the reality is important and the efficiency is important. I think that is the part we should collaborate in our intelligence with machine. So based on that, I think each individual, every office will have your own style because we still have human being there. But I think what our position, vision is we should open our mind to this kind of new intelligence, including the computation, including the robotics, because these intelligence can expanding our skills. Either it could be more efficient in different projects, or we can make different kind of paradigm shift, right, based on different collaboration intelligence. So that is something I think for the pedagogy system, the same for the future. It's like the intelligence is part of the new future, which is become a new authorship, because based on like PhD program, we have a lot of PhD international and local PhD students, and all of them will have their special contribution based on this kind of software culture, because they can have their own plugin, for example, a structured plugin or the robotic plugin files. That is their intelligence to make their contribution to the society. I think that is the intelligence we can give more possibility and to make the problem more interesting. Is not so by the same way, maybe we open the window, it's totally can open a different solution based on different kind of intelligence. So that is what we're very interested in that. But honestly, as a designer, everyone should have your specialty authorship. But I think the authorship from my office is not just from us. It's from the collaboration with the society. It's a collaboration with different kind of research work. So that's what I want to say today.
Thank you so much for this wonderful lecture. My question is simple: is where does tradition and culture begin, and where does it end in the world of machine intelligence?
I think from the very beginning, I'm talking about our last 10-year experience in our office, for example. That is our culture attitude. It's a courtyard culture, and we embracing this kind of that's a very local actually scenarios actually where we live and where we construct everything, which is not just physical space. We have beside that, we have some content like research works happening in this space. I think the local scenarios, environments, which is just a platform or scenario, because we have some like very abstract or some other platform. It's not a physical platform, a physical environment where we live. We have a global society community. I think which is really important to us to embracing the kind of new technology. But at the same time, we locally have a physical space. I think the physical space here is not 100% of what we're doing. I think more than 50% maybe, because locally we need to find the special tectonics and the budget to build these kind of things. So the tradition lies in the process. I think that's a kind of real process. It's not just borrowing from the others. If you want to really doing this kind of thing, you need to collaborating with the networks, which is real. So I think I would want to put forward what is the local, what is the cultural things is you need to engage really to the social process. I think that lies in not just like in the university, but lies in the whole social networks. But as an architect, I think we should embracing with them, collaborating with them. We should open our mind with them. I think everyday life is here. It's part of our life. and it's part of the future intelligence. I think that is the point I want to maybe not close the door to what is high technology and local culture. I think we're embracing both of them. That should be all important to us, both important to us.